Okay, so this is your class notes for section 2.2. I have some information already written on the board that you should have received from your reading and notes that you did outside of the class notes portion. The work for the class notes, I'm going to add in a blue marker, and you need to add that information in underneath the bold headings. So we'll start with section 2.2. This is a description of mixtures. There are two types of mixtures that we talk about and are concerned with in chemistry, in this chemistry class, which is heterogeneous mixtures and homogeneous mixtures. So heterogeneous mixtures, by definition, we have a composition that is not uniform throughout. So I'll give you a couple of examples. A sand and water mixture would be heterogeneous. So would, in some non-chemical type terms, non-chemistry terms, a salad with different things in it. So would chicken noodle soup. So wherever you look, it is not uniform throughout. Let's describe that in terms of phase. So the term phase refers to any part of a sample that has uniform composition and properties. So if we have something that's not uniform throughout, that means that that heterogeneous mixture will have two or more phases. For the next one, a homogeneous mixture, we define as the composition is uniform throughout. That means that the sample has only one phase because all of that particular mixture has the same composition and the same properties. So for example, salt water mixture would be a homogeneous mixture, as would Gatorade, powdered Gatorade in water put into solution once it's all mixed in. Every part of that has the same composition, even though it's a mixture. So for a heterogeneous mixture, we'll only have one phase. So any part of that saltwater solution that you were to sample will have the same composition, the same makeup of water to salt ratio, and the same properties. So now let's look at class notes for 2.3. For this, we're talking about not mixtures as far as type of matter, we're talking about substances. Sometimes those are called pure substances, but that's a bit redundant because substances would have to be composed of only one type of matter. Okay, so we'll start with our elements and compounds. So these would be under substances as we look at a matter flow chart, which we'll address in a little bit. Elements are going to be defined as the simplest form of matter that has unique properties. If we want to find particular elements, we would look at our periodic table. So I have a periodic table here, and I will just pull a couple of element names: boron, carbon, oxygen, and we'll put those as examples. Again, if you're not sure if something is an example of an element, you would need to refer to the periodic table. Again, your definition, that would be the simplest form of matter that has unique properties. The next type of substance that we're going to look at is a compound. Now, a compound is a substance that has two or more elements, so maybe it has oxygen and hydrogen, that are chemically combined in a fixed ratio. So these two or more elements that are chemically combined in a fixed ratio give us a compound. Chemically combined is another way to say bonded, okay? I'm going to give you a couple of examples here that are different compounds formed from just hydrogen and oxygen. The first is H2O2, and the other is H2O. So H2O2 is two hydrogens and two oxygens combined that form a compound we call hydrogen peroxide. The other that is a combination of hydrogen and oxygen is H2O. Now, you wouldn't think that one difference in an oxygen would make a huge difference in this compound and properties, but it actually does. If we have different ratios, that means we have different compounds. So different ratio equals different compound. The next thing I'd like to do is talk about chemical changes. So for chemical changes, we define chemical changes as the change that produces matter with a different composition than the original matter. So a chemical change produces a new substance. And we can look at this as a new substance is going to be formed. So you can add that to your original definition. An example, or some examples of new substances formed are heating sugar to break it down, okay. Second example would be running electricity through water to split it into hydrogen and oxygen. Running electricity through water to form hydrogen and oxygen gas. And the last example is burning paper to create CO2 and H2O. Combustion reaction. So burning paper to form CO2 and H2O. Okay, so we can see that in all of these cases, we are going to end up with a new substance form. When we break down sugar, we get carbon, and we also get water. When we run electricity through the compound water, we form oxygen and hydrogen. Those are new substances. When we burn paper, which is a hydrocarbon with oxygen compound or mixture, we get CO2 and H2O. Next, we're going to look at the matter flow chart that you have at the bottom of the page of 2.3, the beginning pages of the 2.3 notes describing elements and compounds. This is really key. I want you to understand that when we have the overarching matter as a huge category, we can break that apart and look at the two types of matter. Those are going to be substances, which we just talked about, and mixtures, which they referred to in 2.2. Under substances, substances, or sometimes called pure substances, can be broken up into elements or compounds. Elements or compounds. Element examples, again, look at your periodic table. Fe, that's iron. H, that's hydrogen. Hg, that's mercury, etc. For compounds, those would be things like CO2. Remember, it's two or more substances that are chemically combined, bonded together. C6H12O6, etc. Okay, many different ones. We talked about water, H2O. So elements and compounds are related in that if we combine elements chemically, we get compounds. So this would be a chemical change. Conversely, we can break down compounds and form the elements or end up with the elements that they came from by breaking them apart and having a chemical change occur. On the other side, we've got this mixtures, which we know we can have heterogeneous mixtures. Okay, and we can have homogeneous mixtures. Just to remind you, heterogeneous, this is 2 or more phases, and it is not uniform throughout. So that might be a sand and water mixture. Another example of a heterogeneous mixture would be, and this is easy to picture, maybe chicken soup. Okay, that's more something we deal with in our daily world. Okay? For a homogeneous mixture, remember these have only one phase. So this would be something like salt water. When the salt is fully dissolved. A homogeneous mixture, a solid example would be steel. The steel would be a mixture of iron and carbon. And another example would be air. Air should be a homogeneous mixture. I'm putting air because air is kind of an interesting descriptor. Okay. One last piece of this flow chart is that we can go from substances, either elements or compounds, to mixtures with a physical change. And if we have a mixture, we can separate using physical means to get the individual substances out.